this is the demonstration video for IPv4 addressing scheme. So let's start the demonstration. So firstly, let's know what is an IP address. So IP address is a numerical label assigned to each device connected to a computer network that uses internet protocol for communication. It serves two main functions. First one, identifying the host or network interface and providing the location of device in the network. Then let's jump to the IPv4 addressing scheme. So IPv4 stands for Internet Protocol version 4. It is the fourth version of Internet Protocol. It uses 32-bit addressing scheme, allowing the total of 2 raised to power 32 addresses over 4 billion addresses. IPv4 address are typically represented in dotted decimal notation like 192.0.2.1. So now there are three types of IPv4 addresses. First one is unicast. Unicast is an IP address that identifies a unique node. Means it identifies a single network interface and is used for one-to-one communication. Then the second one is multicast. IPv4 addresses that identifies a group of devices interested in receiving the same data simultaneously. And the last one is a broadcast. So broadcast allows the communication to all devices on a specific network segment. Then it comes to classful addressing. In the early days of internet, the IP addresses were divided into five categories: class A, class B, class C, class D, class C. These classes determine the size of network portion and the host portion of the addresses. However, the system led to an efficient address allocation was replaced by classless interdomain routing CIDR. So there are five classes. First one is a class A. Class A addresses are intended for large networks with millions of hosts. It ranges from 0 to 127.255.255.255. Then it comes to class B. Class B are suitable for medium-sized networks. Its ranges from 128.0.0.0 to 191.255.255.255. Then there is class C. Class Cs are for small networks with few hundred hosts. Its range is 192 to 223.255.255.255. Then there is class G. It is also known as multicast. Then the class Gs are for multicast groups. Its range is from double to 4 to 239.255.255.255. Then there is the last one, the class E, which are not commonly used. Its range is from 240 to 255.255.255.255. Then let's jump into CIDR. The CIDR is a method of allocating IP addresses and IP routing. It allows for more efficient allocation of IP addresses than the original class-based system by providing a way to specify the network portion of an IP address and the host portion separately. So then our next part is subnet. So subnet is a logical subdivision of an IP network. It allows a single network to be divided into multiple smaller networks, each with own range of addresses. Subnetting helps in efficient utilization of IP addresses and better network management. So it helps to divide this type of single network which is a single IP. And then after subnetting, within this network we can make four different subnets with four different IP addresses. So next one is IPv4 address to bits conversion. So the IPv4 address is a 32-bit 4-octet address. So its first octet is of every octet is of 8 bits. So while if you break this IP address like 192.168.1.45, So the first octet 192, it can be represented in binary language like 111000000. As the computer understands only binary language, but we are assigning it to decimal format, so the computer first converts the decimal format to the binary format. So the every octet is represented in a format of 8 bits, which comes to a total of 32 bits. Now, as you can see, this one is the IP address of my computer, of my laptop. So while breaking each octet into the binary conversion, like 192211000000 and 16810101000, these are the binary conversion of this. Now the IP address which we tell the computer in a decimal format, the decimal format is converted into binary format like this. Every bit is every octet is converted into binary format. And the IP address consists of two parts. First one is the network part, and the second is the host part. The network part, it is the part of IP address that identifies the network to which the device belongs to. It specifies the network address and is used by routers to define how forward packets within the network. The size of network part is determined by the subnet mask. The subnet mask is a 32-bit number that consists of a series of consecutive ones followed by a series of consecutive zeros. The number of ones in the subnet mask indicates the size of network part. For example, if the IP address is 192.168.1.0 with subnet mask of 255.255.255.0, the network part is 192.168.1. So, as you can see, in this example, if these are the three networks, then the subnet part will be the common part in these three IP addresses. Like in these IP address, the common part is 192.168.35. So this part is known as the subnet part, and the rest is called the host part. The host part identifies a specific device within the network. It distinguishes one device from another with same network. The size of host part is determined by remaining bits in the address after network part. So I have seen. So this 17, 18 and 19 represent the host part. Now comes to IP address allocation. The IP addresses is managed by uh, regional internet registries which distribute the addresses blocks to internet service provider and organizations based on their requirements. Then it comes to dynamic IP addresses and static IP addresses. So, and static IP address is an IP address that is manually configured for a device and remains constant over the time, while the dynamic IP address is automatically assigned to devices by a DHCP, dynamic host configuration protocol server, and may change over the time. Then these are the there is a challenge with the IPv4 addressing scheme, that is the rapid due to the extension of internet, the IPv addresses are uh, there is a depletion of IPv4 addressings. So the IPv4 address has exhaustion due to limited number of available addresses, as only 4 billion addresses are available in IPv4 addressing scheme. So this led to the growth of IPv6 addressing scheme, which is accommodable to future growth. Then let's understand the IPv6 addressing scheme. So the IPv6 addressing scheme is the most recent version of Internet Protocol designed to succeed IPv4. It uses 128 bits for addressing and is represented in hexadecimal format. So it offers immense advantages. It offers larger addresses space, ensuring abundance of available addresses for future needs. Then this is the difference between IPv4 and IPv6 addressing scheme. So IPv4 uses 32-bit addresses and divided into classes A, B, C, D, and E with subnetting, while the IPv6 employs 128-bit addresses, facilitating vast number of unique addresses with enhanced security as compared to IPv4. While there are other advantages also, like it is offers large address space, improves security, simplified network configuration, and enhanced port of technologies. Also, due to the limited space of IPv4, it leads to exhaustion, complex network, and security vulnerabilities. So these are some limitation, like IPv4 has space limitation, while IPv6 is virtually unlimited address space. It supports multiple mobile networks and IoT devices. It has built-in security features. So the IPv6 is the new upcoming uh, scale of the IPv4 addressing scheme, and it is the future of IP addressing, and it is used in many technologies like such as 5G and IoT, which will drive for the demand of IPv6 addresses. And the importance of IP addressing is vital for building and managing modern networks. It is increasing day by day with the demand of IPv6 addressing scheme. Then these are same the differences of IPv4 and IPv6 with the subnetting and the advantages. IPv4 to IPv6, as the IPv4 various methods such as dual stack, tunneling, translation facilitate smooth migration from IPv4 to IPv6 addressing scheme. So this was all about the demonstration of IPv4 addressing scheme, and if there is any query, kindly try to mail me at this email ID or at my phone number. Thank you.